And in C++11, null PTR, null pointer, this one, is newly introduced. Null PTR is a special constant value that is used the same way as null in C, but it can only be assigned to a pointer. So null PTR is not the number 0. Note that if you are aggressively programming, null is same as 0, but null PTR is different to number 0. So you can use null PTR to differentiate between null pointer and the number 0, which cannot be done with this null. So why do we need null PTR, null pointer? So if you look at this code, this is a function overloading. Two functions have the same name, but because the parameter types are different, it is valid syntax. We learned function overloading before. So assume there are two functions, functions, with one receiving pointer variables and pointer parameters, and one receiving int value. So which function will be invoked if we code func with null? Which function will be called with this one, function call? Since null is the number 0, both are equally valid, so we don't know which function will be executed. So C++11 resolved this problem by introducing null pointer, null PTR. So use null PTR anywhere you would have used null for pointers. For example, like this, null PTR instead of null. So if you make a function call with func passing null PTR here, these functions will be called because null PTR cannot be number 0 and it's just null pointers. So null PTR is not int type, so this will not execute. This one will be executed. So use null PTR for pointer variables. So I think that's enough for the pointers. Let's talk about the reference. We have already learned about reference briefly when we were talking about call by reference in function call. In C++, for call by reference, we can use both reference and pointers. And reference is newly introduced in C++. C does not have reference types. And we can declare the reference variable by specifying ampersand after the type, so like this. And you can think reference variable as an alias or an alternative name for a previously defined variable. So it is very similar to pointer, but it is more restricted compared to the pointer because reference variable cannot have a null value, whereas a pointer can have a null pointer. So this is a concrete example of reference variable. Here we declared Bob as a reference variable, and Bob is an alias to Robert. So if you change the value of Bob, it will affect the robot as well. And like this way, you can declare multiple references on the same line, on one line. If we compare to the reference with pointers, reference cannot have a null value, and it cannot be reassigned. So you can think reference as a const pointer, and you should initialize reference variable when you are declaring it. So initialization and declaration must come together. And references share the same memory locations. Let's see this restriction with the example code. So so if I run this program produces this output. This program has a int type of variable a and b, which stores 3 and 5 respectively, and it has a 2 pointer, po1 and po2. po1 points to the address of variable a, and po2 stores the address of po1. So po1 and po2 are pointing to the same memory location, which is the address of a variable. And here we are declaring the reference variable re1 and re2. So re1 is an alias, which is an alternative name for the variable a, and re2 is assigned with re1. So re1 and re2 both are alternative name for the variable a. And if we print the address of 2 pointer and 2 reference, the address looks like this one. As you can see here, even though 2 pointers pointing to the same memory locations, the address of the pointer variable itself are different. One ends with 8, one ends with 0. But if you look at the address of the 2 different reference variables, the address of these 2 reference variables are the same. So they share the memory address. So these are the big difference between pointers and reference variable. And we said that we cannot have a null value to the reference variable. So if I compile this, it throws compile error message because of this. We cannot have a null value to the reference variable. And the initialization and declaration must come together. You cannot do this. Here we are declaring reference variable and we are initializing in the next line, but you cannot do this. We have to combine declaration and initialization together. So if we compile this, oops, sorry, so this one. It produces a compile error, so you cannot do this. Okay, so let's go back to the slides. Okay, so that's it for reference. Let's revisit array pointer, which is confusing. Array pointer is not new to C++. You can use array pointer in C. So many of you might already know what array pointer is if you took C programming course before. So here we have a array variable which can hold the 5 int value, and we are assigning array pointer array variable to this pointer variable. So if you do this, this pointer points to the zeroth elements of array, this array. So this pointer points to this address. But this is a array pointer. The syntax is that we put data type here, which is int, and we put the variable name and the asterisk here. Variable name is a ptr2 and asterisk here, and we put the array size here. So this is how you declare the array pointer. And if you assign the address of this array like this, this ptr points to the whole array, not just this first zeroth index of elements. So these are the difference between this one and this one. This one just pointing to the 0th index, and this one points to the whole array. And you can also make array reference similar way. Instead of putting the asterisk here, we put the ampersand here like this. So ptr3, so this is a typo, it should be 3. ptr3 is an array reference of this one. So okay, let's see the demo code for this one.